Everyone, in this video I'd like to introduce how to handle data, and we're going to be do something like this in the future. So let me use this opportunity since somebody asked. I'm going to use this opportunity to introduce how to do that. First part is going to be generating x values. So I typed it here. For if you use this command srange, then it means it's starting from 3.4 and increasing every time by this 0.7 units and all the way up until this value is strictly less than 5.4, and next number being equal to 5.4 or exceeding 5.4, it'll stop and generating that. So I'm going to show you how this one looks like. Now here it's S3.4. If you add 0.7, and that's going to be 4.1. If you add 0.7, it's going to be 4.8. If you add 0.7 and then it exceeds 5.4, then it'll stop in generating these three numbers. Or you can just type it like this manually and then give generate a list. So these are ways of generating x values. Next portion is about generating y values of the functions. So first we have to define the function. I think I explained this one in class. It's safe for us to call I make this x as a variable, and then you define a function this way if it is given by a simple formula like this. And next part is that we want to go ahead and plug in each of this value into this function and generate the y values. So the way it's done, it's a repetitive way and doing the same thing. First you choose the first element and stick it in there and calculate, and go ahead and choose a second element and plug it in there. So except that choosing the different element, what we're doing with the function is kind of the same thing. Whenever we do that, we call it a loop in the computer language. So we're going to do the loop, and here the language is for. We just start the for xx, and this is representing the entries here. It could be any letters you can choose. It's coming from that x we defined it earlier in here. So xx will be this number, and after that it's going to be this number, that number, and the fourth number, and things like that. And you have to end it with this colon, and if you hit enter, it does automatic indentation. And here we're going to do the y value. We're going to calculate the y value, and it's going to be f of that input value we chose. I forgot to define the list of y, and going back and inserting the line. This capital Y will be this empty list, and every time when we calculate this y value, we're going to put it in the one at a time. So at this stage here, we calculate the y value, and this is where we're storing this y value into the list of y values in here as empty list right now. Now this is a command, y dot append that value you just calculated, and this will store that. And these two lines will be repeated over and over, and if this is the end of this for loop, if you go back, and xx will be the second number, and you evaluate it again, and then there's different y value stored in and appended to this list again, and third value, and you calculate it again, appended to that list, and then so on. So when you reach the last entry, we do that and it escapes the for value. If you hit enter in here, it's going to keep allowing you to enter the third line in the for loop, but if it's end of it, you have to just go to the first position, and it indicates that it's end of it. So if you want to see what's in the y, then you just simply have to type y and hit shift enter, and it's going to calculate the values in there. And then go back if you want a y value truncated as a numerical value, not too many. Maybe if you want 5 values, and you can insert it here. You renew your y value with a numerical value with digits, maybe 5 digits, and it's going to generate only a 5-digit expression in there. And down here, I'm going to also show you that rather than just separating x values and y values, often useful to generate as a pair up like this, x comma y, rather than just generating a list. So I'm going to copy and paste. Rather than just storing it as a y value, we store it as a point like this. So copy them down here, the same thing, the variable x and same function, x cubed plus 1. This time it's not going to be the list of values, but list of points. So we do the same thing, we pull out x values from this list and calculate the y value and truncate it down to the 5th decimal place. Rather than storing this one as a value, we're going to store it as a point. So here's the empty list at the beginning stage, points list, and we're appending not a number, but a point like this in xy forms. The x value here is xx we chose, and y value we just calculated is a y value. So if you do that part, and that's how it's going to, every time we're going to append not a number, but this xy coordinate points to the list. So the list will not look like a number here, but x comma y here and x comma y there and things like that. So that's the end of the loop. And if you go back to the first position, again, and points list will generate all the points. So let's see what it did. So as you can see, the first point is a 2 and the y value is applied as a point, second value applied as a point, and all that. So that we have, instead of numbers, we have xy coordinates. When we calculate these xy values in one way or another, if we have collected the data and we went through a complicated algorithm, then we get the data to visualize it. Rather than looking at a list of x value there and list of y value there, it's better to just put it into the points and plot these points, and that's the best way to represent functional relationship between this x values and y values, and this is how you actually sketch in Sage. So the command is this list plot. I'm about to plot all these points that I stored in this points list and call that picture show points, and you can let me do that later. So I'm gonna just execute, and this is going to show the picture. So this plot, and here it has to be a list, not a single point. It has to be a list of points as we define it over here. So that's going to be points list. You can put an option, color, red, something like that, and you can also put the size being 20, and this will generate the picture. Scrolling down a little bit, those 4 points in XY plane, it looks like this. But this is generated and disappeared, but if you want to keep it and use for combining with other things, and then here's what you can do. Go ahead and call that one show points, and if you execute this one, and it's not going to show the picture, but to store that picture into that command and continue it here using this command, the show command, you can show that points. Then if you want to add on, add other pictures, then you can also do that by putting the +1. I think I've shown that before. So let me actually do that. The graph was f of x was defined, and this is where it's evaluated. So I'm going to call that on a different figure. Let's say different figure, figure 2. It's going to be plot of the function that's sketched in between, let's see, between 2 and 3.4. That's what I see. So we have x between 2 and 3.4. If you sketch it, that's going to be the graph of this function. If you put them together, and you will see the graph and the points appearing together, as you can see in here, like that. If you want to make point size a little bit bigger, and then you go make it about that, make it a little bit bigger, then it's going to show a bigger points in there. As you can see, it's kind of the points is hidden below, and to control this one, make sure the dots are appearing above this picture, you have to use something called the z-order. So if we put the z-order, I think it has to be 3. I don't know exactly why it works like this. I think it's the XY plane itself counted the first one. That was the third one put on top of it. Maybe I should do something like this. If you put the order, and you can see the point is on top of the graph, so that you don't see that line that's crossing inside the dots. Putting that, it controls that. So putting this points in XY plane, it is a really useful idea to visualize the data set you have. So and this is how you do it.